But I mentioned also that there are two main types of discrimination that economists tend to think about in the labor market. Case-based discrimination is one of them. The other one is called statistical discrimination. So we're going to talk about that as well. So if you recall, I don't have a way to put this up on the screen, but we played the game last time. We played the game with the cards, right? And in that game with the cards, right, we had a, I'll go back to the beginning, I guess. We had two different types of cards. We had red-backed cards and blue-backed cards. The red cards went from 2 to 6. The blue cards went from 4 to 8. You had to show the color of your card to the potential employers, but you were not allowed to show the number. And then there were employment deals going on, and you settled on wages and things like that. And the numbers that we ended up with, I guess I can just look and recreate it on the board. So we had blue, the average payment for blue cards, and the average payment for red cards. Round 1, round 2, 6.3, 5, 6, and 4.75. Any guesses? What's the Nash equilibrium of this game? Any guesses on that one? If we played this game over and over and over and over again, what would incentives push the wages for the blue and red cards towards being? Any guesses? Well, it would be 4 for the red cards and 6 for the blue cards. Because on average, what does hiring a person with a blue card and a red card get you? On average, the blue card gets you paid 6, and on average, the red card gets you paid 4. So you'd be willing to pay up to 6 and 4 respectively to hire somebody with that color of card. And we didn't get exactly there, but we were sort of heading in that direction, right? For blue, we were sort of hovered around 6. For red, we started at 5, and we were already starting to drop by round 2. Again, brings us to statistical discrimination. So statistical discrimination is discrimination based on when people make blanket assumptions about a person based on what group they are in. You can sort of think about it like stereotyping, but it's a bit broader than that. Now, these assumptions may or may not be true for the group as a whole, but the thing that makes it definitely discrimination is that they are applied to each individual, whether or not it applies to that actual individual. So as in this example right here, you can imagine comparing two different people, right? Imagine a person holding a blue 5 against a person holding a red 5, right? Those two people are equally skilled, and yet, because they can't actually show their 5 to the person, the person with the red 5 is going to end up likely being paid less than the person with the blue 5, right? Equally skilled, but getting paid different amounts, which is a wage differential, right? That's not based on human capital. So why does this happen? Well, it happens partially because somebody's true productivity cannot be observed, right? So if you're an employer, you're hiring somebody, you don't know how good they're going to be. There's an information problem, right? We already talked about this when we talked about asymmetric information. You don't know how good of a worker that person that you're hiring is. And so you try to make an assumption about how effective a worker you think that person's going to be, and you use the signals that are at your disposal. And those signals might end up being based on demographic groupings or things like that, right? If you think people from group X have a marginal productivity of labor of 10, you will assume that a person from group X will have a marginal productivity of labor of 10, no matter what their actual individual marginal productivity of labor might be. So you'd offer them a wage on the basis of them having that value, whether or not it's true. And you do this whether or not that person actually has a marginal productivity of labor of 20, in which case you'd be underpaying them. Or even when it's accurate for them. Even if it's accurate for them, right, it's still an example of statistical discrimination because that's where the wage offer is coming from. So this is exactly what happened in our game. So somebody with a red 5 was just as good as a blue 5, but they were not able to actually reveal their productivity. And as a result, we ended up with wage differentials between the different people based on the color of the card that they held. Because employers could not see the actual number, they had to make an assumption based on the back of the card. And the statistical average based on what you know about those distributions was that the wages would be a little bit lower for the red than for the blue. So I want to know what wage to offer you, but I don't know your actual marginal productivity of labor. I got to make a guess somehow. I use whatever information is available to me, which includes what group that you are in, which means that group membership can lead to discriminatory behavior on the part of the employer because they are trying to use that information to guess your marginal productivity of labor. So I'm going to use my assumption about your skills and my offer on the basis of what I know, or at least what I think I know about that group. So what does this actually end up doing, right? Well, if you happen to be in a group that employers perceive to be less skilled, then you're going to get offered a lower wage, even if you are in fact quite highly skilled. Or even if the group is actually quite highly skilled, but the employer misperceives it. This is an asymmetric information problem, so we can solve it at least partially with asymmetric information problem solution. Signaling, for example. One example of this is education. In education, we tend to find, I'm an education researcher, I do a lot of research on the labor market of education. What we find is that the return to education, the additional money that you earn in the labor market related to your education, tends to be higher for disadvantaged racial groups. We can imagine why this might be related to statistical discrimination, right? If the problem is an information problem, then being from a disadvantaged group, being able to prove yourself and do the hard thing, you would expect to give you a bigger jump because it is fighting off a different kind of assumption that the employer is making about you. So that's another way in which we can get wage differentials on the basis of discrimination and statistical discrimination. The reason why economists tend to think of them in two different ways is because they work in very different ways in the labor market, right? An easy mistake to make is to think that because this is based on some sort of statistical idea and there's not an explicit prejudice baked into it, that it's like not as bad, but that's not really how it works. It actually can be, in some cases, have worse effects. Because unlike taste-based discrimination, there's no reason to expect that statistical discrimination will go away on its own. Right? Remember this graph back here, right? For taste-based discrimination, it is an unprofitable thing to do. You will be outcompeted by other firms who are not discriminating in the same way. But that's not the case for statistical discrimination. Right? As long as the estimate of the average is correct, meaning as long as the stereotype is true on average, even if it's not true for individual people, that's how stereotypes work. They're not true for individual people. They're true, at best true on average. Practicing statistical discrimination may actually be the most profitable strategy, which means that it would not by itself go away just on the basis of the market. You need something else there as well. But just because it is profitable does not mean it's not harmful or unfair. Right? It doesn't make it just because it's not based on explicit prejudice. It's still based on things like stereotypes, and it still hurts people. It is still around, right? So it doesn't go. I mentioned the graph earlier with that sends out fake resumes, and it just sort of randomly assigns a bunch of attributes on a resume so that they're all the same resume on average. Then just varies like the name that's on there, so you can see how employers respond to different kinds of names that they see. You do see that there are big differences in terms of who the employer calls back based on just the name, right? So again, the exact same resume information, get very different callback rates. This happens across racial lines. Here's an example from 2004 in Boston and Chicago. Here it happens across immigration lines. So this is from Toronto, using some of the major immigrant groups in Toronto, getting much lower callback rates, even with the exact same resumes otherwise.